Hey guys, welcome back to the shop. In this video I'll be showing you a bunch of these copper jaw sets that I've made, and I'm going to be fast forwarding through most of it, just doing a little montage of everything. I don't want to bore you to death. It's been about a 25-hour job over the span of a few days. It's pretty much consumed the whole weekend. We've almost got it knocked out, but we have a set here. Okay, we've got us a set here that he wanted, my customer that is, wanted a set of Wilton 600S jaws, which are 1 inch thick. He wanted them in solid copper until he checked the cost of inch thick copper bar by 1.5 inches tall and 1 foot long for each pair. He wants 2 sets. So we worked with him on making these half and half. So as you'll see here, these are still, they need milled on the side, and you'll see that. We have milled out these in pairs. So imagine this is the back of the vise right here, back of the jaws. He's gonna have replaceable copper soft jaws on this. The backs are gonna be the regular A2 hardened tool steel. And if for some reason he wants to switch and take these jaws off, he can switch out to brass, he can switch out to aluminum. He can use it like this, just the half jaws, which they're not exactly half and half because he wanted 5/8 copper on the front. So here's what we're gonna do. We are going to drill and tap these in 3 locations. And they are going to thread in to here. They're going to be counterbored. And then these jaws, if you're familiar with Wilton style vices, they bolt in from the back. So they're going to be threaded on their 4-inch on center from the back. And then these bolts are going to lay in between there or outside of there. I haven't decided yet. And they're going to thread in from the front. And the reason we don't go all the way through and thread into the copper is because of just how soft the copper is. I mean, this stuff, it is extremely soft. So I figured we'd make a short video about this and how I plan to make these. Again, these are going to be replaceable soft jaws on the front, permanent hard jaws on the back. And that'll allow him to use his Wilton 600S however he wants to use it. So we're going to get this taken care of here for him. All right, let's get to it. And sorry you're seeing so much of the same thing. A lot of my business is making vise jaws, but you will be seeing all kinds of custom work and some welding, a lot of lathe work getting ready to come up. I'm just trying to catch up on all these vise jaws. I had about 45 sets on order. I'm using a 1/4 inch end mill, and we're doing for the helical through hole, we're doing around 8 inches a minute, and then for all the pockets we're doing 20 inches a minute. On that finished pass you saw was 12.5. I'm done. But I would like to convert this to use with USB. I've heard you can do that. R232, whatever that means. No idea whatsoever. So we're gonna try to figure that out one day too. There's my Mountain Dew timer. Here's the last sets. We are gonna take our vice stop out of there. And we're gonna take the end mill out of there. No, don't turn it on. Crank that back down to about 3,000 on. And we're about an 1/8 inch over on our length and our height, and 1/8 inch over on our thick. All I'm doing is touching off. 0. That's what we're gonna roll with right there. 15 inches a minute, 30 thousandths, 3,000 RPM. All right, I'm gonna swap the inserts. I did do about 4 sets of A2. So they're probably, yeah, they're a little bit wiped and I should have looked at that. I'm gonna change them right here. And I didn't mean change them, I meant just index them. And these are Lamina OFMT inserts. Lamina Technologies out of Switzerland. You know, they're not $15, $20, $30 an insert. They're about $8 an insert, but they do really, really well. Especially on A2, I can get a surface finish just about like glass on those. We're gonna come down to about 35 thou depth. Just to restart, about 3,200 RPMs. Finish on this thing. Where are we? Whoop. Boy, that is ugly. What's going on here? We're gonna run out of room to work. I want to drop those RPMs about 28. Focus. Come back across 30 again. See how ugly that is? Dead on 0. 6 inches. Ooh, just about messed that up. Getting in a hurry here. Started to put the unmilled side instead of the milled finish. That would have threw a wrench into our plans right there. Glad I caught that. We're taking like 80 thou cuts right now. Well guys, here they are. So they're finished up, ready to be paired together. So we're gonna drill. Let me show you here. We're gonna drill 4-inch on center threaded holes through all of these. Yes, all the way through. And then for the jaws, I think what we're gonna do is step in and only do 2 jaws, 2 bolt holes. As close as we can get them without interfering with the threaded holes on the back. 625, 3 5/8 center to center. I don't believe there will be any problems with that. But we're gonna do the back ones first because we know what they need to be. So we're gonna do these back jaws first. Hello. And you can watch a little montage. We're gonna find the center off of the fixed jaw. So our center is gonna be 751 down. Oh shoot. Good thing that wasn't the copper one. You can like breathe at it real funny. Look at it the wrong way. It'll mush. Like that. That's what my wife does. Because I stay out here all day. Don't tell her I said that. Make sure you turn the spindle off before you go grabbing your end mills. It's always a smart choice. Ow. These things will kill you, I'm telling you. Pull those in. They are out to get you. We're just finding the center. I look like I'm driving a really funny car, but I promise you we're just finding the center. That's all we're doing. Give her a flick. Not more than once, so you're playing with it. You know the routine. So we are 250 in because radius, because half diameter. So we're gonna go exactly 501. Because when I build them a little tall, like 1 thou tall, I want that 1 thou up. I don't want it down because I have some severe OCD. We already mic'd these 6 inches. So we're going exactly 3. Oop. Let's clean the schmoo off of it. We are looking for concentricity. Concentricity. All right. we're gonna program this. Remember, I take a picture, X and Y ABS. That way I know where the absolute zero of that part is. And that goes for any part with these dimensions in this vise, with the vise stop there. Promise, I'm not lying to you. Look at that. Double axis. Hold up. These are Speed Tiger from Taiwan. Yes, I'm cheap sometimes. They're not like a Goering or any of those nice brands. Really cheap from Taiwan. They are titanium, aluminum, nitride coated. And I've used this at least 10 sets of holes, helical cutting, counterboring of tool steel, and probably 15 sets of copper on this same end mill. That's a lot for a $12 end mill compared to about $35. Are they at the level of some of your nicer brands? No. Are they pretty dang close for the money? Yes. But they are a pain sometimes to get. That's the only thing. I order them in bulk on Amazon. I might order anywhere from 10 to 20 at a time, that way I don't run out, because I do use these a lot. I use my nicer ones for other things. Give them the old college try. You know what I'm talking about. Now we need some paper. You're gonna make sure you're on one thou, that way you don't plunge it and snap it off and run it into your hand like a projectile. Ah! This is a little trick right here. It really puts out a good airflow, acts like a fan. .3/8, 16, 5/16. I knew that. I was just testing you guys. Move your phone so it doesn't get crap all over it. Aren't these copper chips just beautiful? That's it. Okay, 3,500 RPMs. Let's start it. Set tool, 1/4 inch, go, stop. Get out of here. All right, go. Whoop, our feed is too high. We had it advanced 30%. There we go, there we go. Oh yeah. I believe that's the perfect feed rate. You know, we're gonna crank that up to about 38. Yes, sir. Hey guys, so it's a new day. I did mess up this part right here. I didn't put the holes spaced enough. So, our tapping, let's see if I can get you in here. When we tap it, we're going to be into those threads. So I'll show you a neat little way to fix it. You just put an X on it, toss it in the weeds. So what we have to do is do a 5/8/16. 5/16 18 is what I meant. Looks fine to me. Now that we've got these jaws with the holes drilled in them, it's time to tap. I like to hand tap these because I'm extremely strong with these fingers. No, I'm just kidding. I forgot my tap wrench. I have these everywhere. And I like to use spiral fluted taps on just about everything. I know you don't have to. I do like them a lot better, especially tapping. I tap a lot of blind holes. Through holes, it doesn't really matter. It's nice to use a starting tap instead of a bottoming, but other than that, it doesn't really matter. I meant to chamfer these first, but you guys are making me nervous. Why don't you use a milling machine, you may be asking? The Z-axis on the quill is CNC. So it's got the stepper motor on it. So you have to loosen it to be able to do it by hand. And when you type them with a milling machine and you auto reverse, you want it to automatically feed that quill up and down. Well, on that machine, whenever you unlock that Z, unlock the quill, it is an absolute nightmare to get it back. There's something wrong with it. And the Bridgeport stays at a 45, and we are not tapping at a 45-degree angle and setting our parts up like that. So it's just easier for me to do this. I will have a tapping arm though, very, very soon. So you all can quit laughing at me, hand tapping. Quit picking on me. So for now, we just do it like they did it back in the olden days with a tap wrench. I guess. I don't know what they did. We're getting ahead of ourselves, like usual. I'm gonna put some gloves on. Trust me, I'm a doctor. And we're just going to clean it up since the jaws will be bolting on from this side. Back side right here. Man, a flex arm would really be nice right now. If you're not familiar with a flex arm or any kind of pneumatic or electric or hydraulic tapping units, they're super, super nice. You can indicate them perfectly square. You can set it in a machine vise with parallels. You know, you can get that tap perfectly square, run it in, pull it right back out. They have clutches on them, like a tapping head for a mill machine. I will have one day. Alright guys, so I'm finished with the half and half jaws. I figured I'd let you check them out. So I ran out of bolts to fasten all these together, but I've got this one made for you. So as you see, these bolt in from the back. There they are from the front. So together, they equal one of these jaws. Bolt in from the back. These are the surface ground ones that I just finished. You can check that finish out. But there you go. They're completely finished. These bolt together. These bolt from the back. These are Wilton 600S jaws. Right here are the rest of his order. These are all Wiltons. We've got C1s. We've got newer style C3s. I forget the other two here. I apologize, but he's ordered a ton of copper soft jaws. So this was just a random video of me showing you the build process on all these copper jaws. This has been a pretty long job here. There's still 3 more sets of tool steel surface ground jaws to make. So I'll be finishing that up and packaging everything and getting it sent off to the customer. But guys, I really appreciate it. And thank you for watching. And thank you so much for subscribing. We've reached 204 as of this morning. And I really just cannot believe that whatsoever. Until next time, catch you later.